Hey, good morning, everyone. Don Gillis with Emerson. I'm in Sydney, Ohio at the Copeland plant, and hope everybody's having a great day. It's Fun Fact Friday. Hey, I wanted to talk a little bit about enhanced vapor injection or liquid and vapor injection. I think we all know that when we use liquid injection, what we're really saying is we're trying to cool the compressor down with those ultra low temperatures, minus 35, minus 40, is where you'll see it most of the time, if not all the time. Okay, but I want to talk about vapor injection a little bit, only because I got a question or two in the last few weeks through my Facebook page, and I thought I would touch just a little bit on it. And this is just going to be a very generic look at it. Okay, so I've got a lot going on the board. I didn't want to draw it out as I was talking because I thought it would take up too much time. So let me just start out by pointing out the basic system. We've got the compressor, we've got the condenser, we have a metering device, and we have an evaporator. Now, what I've added over here is what we call a heat exchanger, and I'll explain that a little more in depth as we move along, okay? And I've got an EV here also, and I'll talk a little bit about that. So let's walk through the compressor. We're coming out of the compressor, going into the condenser, rejecting heat, as we know. We're condensing the vapor into a liquid, okay? So we're coming out as a subcooled liquid, coming down through here. Now we're going to come through this braze plate heat exchanger, but it's not going to alter anything, okay? It's business as usual. And back to the metering device, through the evaporator, and going to the compressor, okay? Now, what I've changed here is I'm branched off of this liquid line as we leave the condenser, and I've come down here to a EV, okay, to another metering device, and I'm coming through this braze plate heat exchanger. By the way, these are counterflowed, okay? So these are counterflowed. So on one side, think of this as an evaporator on the right side. As it comes through this metering device, it now is a vapor, okay? And this is coming out of the condenser. It's a liquid. They're counterflowing. And what they're doing is we're removing heat from the subcooled liquid to the vapor and picking it up and taking it with us. I'm going to stay with the liquid side for just a second. Notice, hypothetically, I just threw some numbers up here. We've got subcooled liquid at approximately plus 105, okay? As we come through the braze plate heat exchanger, pardon me, we remove that heat. I'm going to say we're going to move around 45 degrees. So now instead of 105 degrees subcooled liquid, we have 60 degrees subcooled liquid coming into our metering device, which helps give us much more capacity on our evaporator, okay? This makes it much more efficient with more subcooled liquid there, all right? We typically would be going in at minus 25, let's say we're using 404A. I didn't look up the numbers, but let's say we're using 404A at minus 25. Now, at minus 25, so that's we're gaining right there on the subcooled liquid side, the capacity on the evaporator. But let's look at the vapor, what we're doing on the other side. We have to do something now with this, where we picked up this heat on the vapor side, okay? So as we remove the heat from the subcooled liquid, think of the right-hand side of this as an evaporator, and think of the left-hand side of it almost as a condenser, if you will. It's exchanging heat, okay? Therefore, the HX, the heat exchanger. By the way, I drew a plate over here to give you a rough idea what that might look like. Let's say the red is the vapor coming through, and the purple, because my blue marker went dry on me, is the liquid, okay? And the plates are pressed together. In fact, I have an example of one right here. Again, it'll come in one side here and leave on this side and the other side. So let's say this is liquid here and this is vapor on the other side. Now these can be used for refrigerant on one side and glycol on the other. You see them in all different types of applications, but that's what it looks like, okay? Now, going back to this here on the vapor side, we picked up that heat, removed 45 degrees of the subcooled liquid. We picked up that heat. We're a vapor over here. So as we know, when we raise the temperature, we raise the pressure. And the whole idea of the compressor is to raise that temperature and that pressure, right? We've got to raise that temperature and pressure because that's what's making everything move around there. It's pumping it around. So if you look at 404A, for example, let me see if I can pull it up real quick for you. So I put minus 25 in there, minus 25, hit done. That's around 12.6. Let's just say 13 pounds. That's about 13 pounds, 13 PSIG on our gauges, okay? Now, if I had plus 50, I would have 103 PSIG, okay, or 104. So instead of going into the compressor at a very low temperature at 13 PSIG at minus 25 and having to do all that work to raise that pressure, to raise that temperature, to hit that discharge line, I'm already injecting this in the intermediate area of the scroll set at 103 PSIG, right in the medium set of the scroll set, okay? So I've already taken a lot of work off that compressor by just using this heat exchanger, by raising the temperature of the vapor, by picking up this subcooled liquid, okay? So I've got liquid coming through the heat exchanger, okay, at 105. I'm removing some of that heat. Again, this is a heat exchanger. Think of the right side as an evaporator, the left-hand side as a condenser. I removed 45 degrees. That's a win-win, okay, because we're getting more capacity out that, the more liquid, subcooled liquid we have, all right? Still going in at minus 25, we're saying, and I just threw out 404A as an example. At minus 25, that pressure is 13 point something, 13.2 or somewhere thereabouts. Now, on this side, we're coming out of the subcooled liquid through a meter device. This all, depending on whose application is, this could also be a solenoid valve. It doesn't necessarily have to be an EV. Some type of controller over here, something reading temperature, maybe an OEM board, depending on whose application they're using our compressor in, okay? Something, though, telling temperature at that discharge line, by the way, communicating either back to the EV or a solenoid valve through the coil, opening and closing when we need that temperature to get cooler inside there. So it's all about keeping that scroll set cool in that ultra low temperatures we're talking about, okay? All right, so we're picking that heat up from the subcooled liquid, raising that temperature. Now we need to go somewhere with it at plus 50 as opposed to minus 25. That's a 75-degree difference, obviously. We're going to go in at a pressure at 103. So we're starting out at 13 PSIG down here. We're already 103 PSIG. So all that work, all that energy the scroll would have had to done inside the compressor is actually being done outside the compressor with this heat exchanger, okay? With very, very little energy. This is the kind of equipment you'll see in our X-line condensers, by the way. This is the kind of things that are in those. You can get liquid or vapor injection with the braze plate heat exchanger. Now we have the digital compressor in there too, which is really cool. Okay, so hypothetically, if this is a 200,000 BT unit, for example, we call it load shifting. We're actually taking part of the load outside of the compressor and moving it over here. Let's say we can get as much as 40,000 BTUs just by using this braze plate heat exchanger, just by those two refrigerants, liquid and vapor, passing each other and using basic physics, hot and going to cold, okay? So that's all I have for you today. That's our Fun Fact Friday. I'm Don Gillis with Emerson. I want to give a few plugs out, something I should have done a long time ago. These are some friends of ours. One of them is an Emerson podcast I want to help promote. It's called HVAC On Air Podcast. Good people, good things are doing it. I listen to it all the time. It's got really good stuff in it. Another one is HVAC Know-It-All. They have a great podcast up there. The HVAC School Podcast, which is another popular one. And then last but not least, HVAC Shop Talk. And I know there's many others, and I'll try to plug as many as I can. I'm going to put some links inside the comment area of some things you can look up on vapor injection, maybe a video or two possibly. So you can help you explain this a little better if you didn't already get it. If you have some questions, shoot them to me. If you're on call this weekend, be very careful. And as always, be safe out there, share the knowledge, and I will see you next week. Thanks a lot. Bye.